Hello from Rocktlab's Mission Control Centre in Auckland, New Zealand, as we prepare for our next Electron mission from Launch Complex 1 on the Mahia Peninsula. It is Thursday, 29th July, and Electron is fueled and ready on the pad as we approach the 6 p.m. New Zealand time launch. My name's Muriel Baker, and it's great to be with you for our live coverage of the dedicated launch of the Monolith SmallSat mission for the United States Space Force. Today's launch window is approximately 2 hours. The weather is looking good, and our operations team are not working any issues with the launch vehicle at this time. So with greens across the board currently, we are on track for today's liftoff. Now, today's launch marks not only our 4th Electron launch this year, but also our return to the pad following an anomaly during our last launch in May. Our flight investigation determined that an issue was experienced with the second stage engine igniter. This was an incredibly unique failure mode that was not identified in our extensive ground testing, including across more than 1,500 Rutherford engine hot fires and 17 successful orbital missions. But with the issue now well understood and corrective measures in place, we are back on the pad today with an even more reliable launch vehicle. We're grateful for the ongoing support of the FAA and, of course, our customers while we worked through the issue, and we're excited to be back to flight today. So now on to today's mission, to launch a research and development satellite for the United States Space Force. The satellite on board Electron today is called Monolith, and it has been designed to test how small spacecraft can support large deployable sensors. The data from this test payload aims to determine whether small satellite buses can be used in future for deployable sensors such as weather satellites, thereby reducing cost, time, and complexity. The mission has been affectionately called It's a Little Chile Up Here, as a hat tip to the beloved green chili of New Mexico, where the Space Force's Space Test Program is based. This research and development mission for the Space Test Program follows on from a previous Electron launch in May 2019, called That's a Funny Looking Cactus, which deployed 3 other 3D satellites for the SCP. Now, these types of space missions flown by the Space Test Program validate fascinating and new technologies that modernize life on Earth and help us learn more about the universe. Early experiments that led to the establishment of the satellites that provide GPS around the world were projects launched by the Space Test Program, and we're thrilled to be partnering with this innovative division once again. Let's check back in now on launch operations and take you through our talented team of operators in mission control. Starting with the front row from the bottom left of your screen, we have our MET operator conducting weather checks on things like cloud cover and wind strength and their impact on the conditions for launch. Next along the front are the RF team, who look after our communication systems between Electron and our global ground stations. At the far end of the first row are our operators managing avionics, otherwise known as the electrical systems driven by software that tell the rocket how to operate and where it should go. On the second row, starting at the far end and making our way back toward the left, the first operator sitting behind avionics is the propulsion engineer for the mission, or prop. They're responsible for the operation and management of Electron's propulsion system, both its hardware and software, and across the first and second stages during all phases of flight. Next to them sits Stage, another engineer who monitors Electron's propellant tank pressures, fuel usage, engine ignition and firing, and overall status of the engines. Moving along, those who sit on the left of the second row are engineers responsible for the guidance, navigation and control of Electron. They monitor onboard navigational systems and guidance computer software on the rocket and are responsible for determining the position of the rocket's first, second and third stages in space. Along the back row at the far end on the right side of your screen is ComOps, who looks after all the data, voice and video communication systems for the launch, and who you can't see in mission control today on the back row normally sits our launch director, Adam Slee. But rest assured, he is on console. He's operating from range control at Launch Complex 1 today. Now, a quick look at the clock tells us we are approaching the final go, no-go poll in a few minutes, which is run by the launch director to determine whether we proceed with the countdown to launch. We'll switch over now to comms from mission control to hear what our operators have to say.
LOX load complete, system in recirculation. Anti-geysering disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge is enabled. Deluge is activated.
T-minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2. Lift off.
We are off the pad and on our way to space once again with successful liftoff from Rocktlab Launch Complex 1. Right now, Electron is travelling at over 500 kilometres an hour and is passing 3 kilometres in altitude. Very soon, Electron will approach max Q, or maximum dynamic pressure, that moment when forces are at their greatest on the launch vehicle. Let's listen in for the call from Mission Control that Electron has passed that phase.
Vehicle is supersonic. Approaching max Q. Cleared max Q.
There's the call out. Electron has successfully passed through max Q. Propulsion is continuing nominally on the first stage as we approach the next event in Electron's ascent.
Altitude is 30 kilometers, speed is 1.3 kilometers per second.
AOS Chatham Station.
First up, the 9 Rutherford
Save
engines will
propulsion
throttle
holding
down
nominal,
before
standby for
shutting
nuclear
off
approximately
completely,
30 seconds.
otherwise known as main engine cutoff or MECO. Shortly afterward, we'll see separation of the first and second stages, followed quickly by ignition of the single Rutherford engine on Electron's second stage.
15 seconds to go.
MECO confirmed.
As you've seen, we've had a successful MECO, stage separation and second stage engine ignition. Next we'll be coming up on fairing separation. This is when the two halves of Electron's fairing separate and fall away in preparation for payload deployment.
Fairing Cheditos succeeded.
And there it is, you saw a flash of it on your screen. The fairing has separated, clearing the way for payload deployment coming up in approximately 50 minutes from now. Meanwhile, stage 2 is continuing well to orbit, carrying the kick stage and the monolith satellite.
Guidance is nominal, altitude is 140 kilometers. We are flying with 3 kilometers per second.
And we are looking at a healthy stage 2 burn at a few minutes and 4 minutes and 5 seconds into the mission. At an altitude of about 10,000 plus kilometers and a velocity of over 165, Electron continues nominally.
Stage 2 propulsion holding nominal.
Our RCS is damping out the roll as well. We've got a little bit of torque coming in from the engine, which is to be expected. And so every so often the RCS fires just to dampen that out. Forms little saw waves on my screen. It's pretty nice.
Space is looking beautiful this evening as our 21st Electron launch has successfully left the pad. We're in the middle of our stage 2 burn, taking us to an elliptical orbit, after which the kick stage will separate in preparation for payload deployment. All systems continue to look nominal.
Now we've throttled down the engine, still looking pretty good.
So for those of you just joining us on our 21st mission, you will have heard from Mission Control that everything is continuing nominally during our second stage burn. Ahead of kick stage separation is the battery hot swap, coming up in about a minute. On our way to orbit, we are travelling at a speed of over 13,000 kilometres with an altitude of over 200.
Battery discharge nominal, approaching hot swap in roughly 30 seconds.
Now for one of the events of the launch events unique to Electron, the battery jettison. The fuel pumps in Electron's Rutherford engines are powered by batteries, but once those batteries are depleted, it's just added weight that we don't need to carry all the way to orbit. So we swap out the depleted batteries for a fresh new one to keep Electron's second stage going all the way. We call this maneuver battery hot swap, and it's coming up next.
Confirmed.
And there it goes. You will have just seen it falling away, meaning that battery hot
looking
swap has
nominal.
been completed. Around 2.5 minutes to go until the kick stage separates, setting us up for payload deployment later in the hour. What we're looking at on your screen there is the glowing hot vacuum optimized nozzle for the Rutherford engine on Electron's second stage. It's the same base engine that we use 9 of on the first stage to do most of the heavy lifting. But when we're in space, we only need one. The vacuum optimized nozzle extension allows us to match the pressure of the environment, unlocking some 5,800 pounds of thrust.
HVB battery discharged holding nominal.
Electron's second stage is now approaching SECO, or second engine cutoff. Much like main engine cutoff, the stage 2 Rutherford will throttle down before the kick stage separates ahead of payload deployment. We are now 8 minutes and 13 seconds into flight, and everything is looking great for payload deployment in approximately 45 minutes.
Guidance is in terminal, 20 seconds remaining.
Stage 2 shutdown.
Stage 3 separation confirmed. And nominal planes to orbit achieved.
And that confirms Electron's second stage engine has shut down and the kick stage and second stage have separated. So the kick stage will now enter what we call a coasting phase while it's in an elliptical orbit before its Curie engine ignites to circularize the orbit ahead of payload deployment. Now, we won't have a live video feed from Electron of payload deployment on this mission, but we will stay with you on this webcast to bring you a simulated view of that happening. We'll take a bit of a break on the webcast now, but we'll be back with you closer to payload deployment to listen in on those final moments from mission control. Payload deployment is expected to take place at about T plus 52 minutes, so we'll see you back here then.
And stage 3 propulsion is nominal. Stage 3 propulsion is holding nominal. And Curie engine cutoff confirmed.
And that is Curie engine cutoff. Next up is payload deployment of the Monolith satellite for the United States Space Force's Space Test Program. Let's listen in for confirmation.
600, perigee 600, inclination 36.997.
And payload separation confirmed.
So there we have it. Welcome to your new home on orbit, Monolith. That completes our 21st Electron mission and officially brings the count of satellites deployed by Rocktlab to 105. Congratulations and thank you to our customers at the United States Space Force and the Space Test Program. It's a privilege to be entrusted with deploying your spacecraft safely to orbit. So we've had a successful Electron launch today, but before long, this rocket's much larger sibling Neutron will be taken to the skies. Recently, we shared our plans to develop a 8-ton class launch vehicle tailored for constellation deployment and even capable of human spaceflight. Neutron will usher in a new era for Rocktlab, supporting our big plans in low Earth orbit and far beyond to interplanetary destinations. And right now, we are hiring. We're currently recruiting talented individuals into the Neutron program across engineering and technical roles in both our US and New Zealand teams. It's an incredibly exciting time to join the team and be part of the next huge step for Rocktlab. So if you think you've got what it takes to join a world-class team making an out-of-this-world launch vehicle, head to rocketlabusa.com. Before we sign off, though, a huge thank you to the many other teams that make missions like this possible, including the FAA, the New Zealand Space Agency, and of course, the entire Rocktlab family. So, with 105 satellites successfully deployed to space, we're going to end today's webcast. Thank you for joining us, and we'll see you again very soon for the next Electron mission. This is Rocktlab Mission Control, signing off.